Welcome. Um, in this video, we will be parameterizing circles. So let's say that we have a circle of radius r centered at the origin in the xy plane, and we want to parameterize this circle. That is, we want to come up with a parameterization of this circle. So what do we have to do then? Well, let's pick a point. Let's pick an arbitrary point xy on this circle, and we need to express x and y as functions of a real parameter t. So that's what we have to accomplish to parameterize the circle. Okay, so how do we do it? Well, so the point xy, let's look at the position vector of this point, and that is, this is the vector from the origin to this point, and let t be the angle between the position vector of the point xy and the positive x-axis. And that's what we are going to take as the parameter, and we're going to express x and y as functions of this angle t. Well, notice that if from the point xy, if I make a vertical line onto the x-axis, then we get a right triangle, and for the angle t, x coordinate here would be the adjacent, and y coordinate would be the opposite. So by using trigonometry, we know that x divided by, remember that the radius of the circle is r, so the hypotenuse here has length r. So x divided by r would be cosine of t, y divided by r would be sine t. And from these two equations, then we get that x is r cosine t and y is r sine t. And so the parameterization of this circle then would be given by the vector function r of t, which would be the position vector r cosine t comma r sine t. Okay, so we have come up with the formulas that we wanted to. So we were able to express x and y as functions of a parameter t, which in this case is this angle here. Now, the question then is, what should t be? What is the range of values for t that we should be taking? Well, that depends. That depends on whether we want the entire circle or part of the circle. Well, if we want the entire circle, and we want the entire circle traced exactly once, then what we want is that we want t to be between 0 and 2 pi. And again, because t is this angle, right? So, and when t is 0, x would be, so notice that when t is 0, x would be r, and y would be 0, so you get this point. When t is pi over 2, then x would be 0 and y would be r, so we are at this point. And when t is pi, you can see that you will get x to be negative r, y to be 0, so we are at this point. When t is 3 pi over 2, we are here, and when t is 2 pi, we're back to this point here. So we see that when t goes from 0 to 2 pi, this circle is traced counterclockwise exactly once. Now, if we keep the same formulas for x and y, but we change the range for t, and we take it, we let t to be we let t to be between 0 and pi. So now what we are getting is we are only getting the upper half of the circle traced exactly once in the counterclockwise fashion. So here, when t is 0, we're here. At t goes to pi, we're here, and we are tracing counterclockwise. Well, what if we want the right half of the circle, the half of the circle that is on the right side of the y-axis? Well, in that case, again, we keep the same formulas for x and y, but we change the interval. We change the values of t. Now we take t to be between negative pi over 2 and positive pi over 2. So when t is negative pi over 2, we get this point. When t is positive pi over 2, we get this point. So we are still going counterclockwise from this point to this point. Instead of taking this this domain, we can also take t to be between 3 pi over 2 and 5 pi over 2, and we still get the right half of the circle traced once counterclockwise. When t is 3 pi over 2, we are here. When t is 5 pi over 2, we are at the top point here. Now, let's say we want to trace the circle clockwise now, and we want to trace it exactly once. Well, in that case, the parametrization that we want to pick is the following. So what I'm doing here is I am replacing, so we have been using these formulas for x and y, and so we are still, so what I'm taking for x is r cosine. Instead of t, now I'm taking negative t here, and for y I'm taking r sine of negative t instead of t. But cosine of negative t is the same as cosine t, and sine of negative t is the same as negative sine t. So now x and y would be r cosine t and negative r sine t, and I'm picking t to be still between 0 and 2 pi. And I claim that now we are getting the same circle, but it is traced clockwise. So let's say when t is 0, x would be r, and y would be 0. So we are at this point. When t is pi over 2, then x is 0, and when t is pi over 2 here, we get negative r here. So 0, negative r, so that's this point here. 0, negative r. And then, at t equals to pi, we will be at this point, and at t equals to 3 pi over 2 will be here, and t equals to 2 pi will come back here. So we see that we are tracing this circle clockwise exactly once if we take x and y in this way. Now, we could have, there is another way of parameterizing the circle with clockwise orientation in a different way. So if I take x to be r sine theta and y to be r cosine theta, and t between 0 and 2 pi. So notice that previously we took x to be r cosine t and y to be r sine t, but now we are doing the opposite. We're taking x to be r sine t and y to be r cosine t, and I claim that if I do that, then I'm getting the circle traced clockwise. Why is that? Well, this time the meaning of t is different. So previously the t was the angle between this position vector of xy and the positive x-axis. Now I'm taking t to be the angle between the position vector of xy and the positive y-axis. Now if you look at this right triangle here, then the the green segment, the length of the green segment, that is actually x, and then this side here is y. So for t, now y is the adjacent and the green side is the opposite. So now I can say that, okay, x would be r sine t, because that's the opposite now, and y would be r cosine t. So let's check when t is 0, which point we get. So when t is 0, we get the point when x would be 0 and y would be r, so we are at this point. When t is pi over 2, x would be, when t is pi over 2, x would be r, and when t is pi over 2, y would be 0, so we are at this point. When t is pi, x would be 0 again, and y would be negative r, so we are at this point. So you can see that we are starting at this point and we're going clockwise, and when x is 2 pi, we'll be coming back to this point again. So this would be a parametrization of the circle of radius r centered at the origin, traced clockwise. Okay, let's compare these two parametrizations. So I have, the same circles here, and for the first circle, so we are picking this, we are taking x to be r cosine theta, y to be r sine theta, where theta is as labeled. Now instead of using t, I'm using theta now. So notice that here the range for theta is from 0 to 2 pi. Here the range for theta is from 0 to 4 pi. So in the first circle, we have this circle, which is we have that the circle is traced exactly once counterclockwise. In the second picture, because the range for theta goes from 0 to 4 pi, so what's happening is that we are tracing the circle twice. Now here we still have in the first figure here, the x is r cosine theta, y is r sine theta. I have a typo here. This should be a theta, and theta is again this angle here, which I took, which previously we labeled that as t, but okay, so theta is this angle. So in the first figure, theta is between 0 and 2 pi, x is r cosine theta, y is r sine theta. In the second picture, x is r cosine 2 times theta, y is r sine 2 theta, and theta is between 0 and 2 pi. Now what's the difference between the two? Well, we know the first one already, that the first one is a parametrization of the circle where it is traced exactly once counterclockwise. What's going on in the second one? So the difference is now we have 2 theta instead of theta. Well, what's going on is that as theta goes from 0 to 2 pi, notice that 2 theta varies from 0 to 4 pi. So notice that when theta is 0, when theta is 0, we are at the point right here, which is r comma 0. When theta is pi over 4, notice that when theta is pi over 4, 2 theta would be pi over 2. So when theta is pi over 4, okay, so I have another typo here that I just realized. This is not theta, this is 2 theta. This has to be 2 theta. So when theta is pi over 4, 2 theta is pi over 2, and then when theta is pi pi over 4, we are at this point here. This is where we are when theta is 0. And what's going to happen is that when theta is pi over 2, we will be here. When theta is pi over 2, and we'll be here when theta is okay, so this would be when theta is 3 pi over 4. And then we come back to this point when theta is pi again. So we come back here when theta is pi again. But now, we still have to go from pi to 2 pi. So when, which means that you're going to trace it one more time. So this parametrization here is tracing the circle of radius r centered at the origin twice. Now, if we think of this, in terms of a bug moving on the circle, then the bug on the first figure is moving slower than the bug in the second figure. That is, because of this 2 theta, what's happening is that this bug has twice the speed of the bug given by this parametrization. Okay, so let's look at the case when r is 3. So if I have this parametrization of a curve C, well, that's the circle of radius 3 centered at the origin that we have already seen. But let's say we didn't forget about the discussion that we have done so far. Let's say I'm given this equations. How do I figure out what curve it is? Well, notice that if I look at x divided by 3 and then y divided by 3, then I get cosine t and sine t, and then if I square them, I get x over 3 squared plus y over 3 squared, which is cosine squared plus sine squared, which would be equal to 1. So then I get that x squared over 9 plus y squared over 9 is equal to 1. So then I get x squared plus y squared is equal to 9. So that tells me that we get a circle of radius 3 centered at the origin. And do we get the entire circle? Well, if you look at the behavior of the function x here, you can analyze that and see that x when t is 0, x is 3, and then as t progresses to pi, x would decrease to -1, and then as t progresses farther from pi to 2 pi, x increases again back to 1. So since x goes to the left and then comes back to the same point to the right, that tells us that the circle is traced once counterclockwise. So that's another way of looking at this. Okay, so I think I am going to let's see. If I have this parametrization, then we know that this would be x is cosine t, y is sine t, t is between 0 and pi. So from our discussion earlier, we know that this is be a circle of radius 1 centered at the origin, but we only get the upper half of the circle because t is between 0 and pi. Here again we have x is cosine 2t, y is sine 2t, t is between 0 and 2 pi, In this case, recall that it'll be a circle of radius 1, centered at the origin, traced twice because of the 2 here, and because the range of t is from 0 to 2 pi. So finally, I want to finish with this example. So x is sine t, y is cosine t, t is between 0 and 2 pi. Now, previously we looked at an example where we had an r here, and we saw that that was a circle traced clockwise. So this would be a circle of radius 1 traced clockwise. But if I didn't know my previous discussion, and another way of looking at it is that you just see that x squared plus y squared would be sine squared plus cosine squared, which is 1. So because x squared plus y squared is 1, then we know that this curve is part of the circle. And then is it the entire part of the circle? How is it traced? Well, just look at the behavior of x as a function of t. So notice that as t goes from 0 to pi over 2, x is increasing from 0 to 1, and then as a function of t. So when t is pi over 2, you get x to be 1. And then as t goes from pi over 2 to pi, x decreases from 1 to 0. From pi to 3 pi over 2, x decreases further to -1, and then it increases back to 0 in this range. So what's happening is that when t is 0, x is 1, and when t is 0, x is 0, so we are right here. When t is 0, x is 0, y is 1, we are right here. So x starts at, when t is 0, x is 0, and then at pi over 2, x is 1. So x is increasing from 0 to 1, and then it decreases all the way back to -1, and then it comes back to 0. So that tells you that you're starting at this point, then you're going down, and you're going farther down here, and then you're going here, and then so it shows the fact that x is moving from 0 to 1, 1 to -1, -1 to 0. That tells you that we are tracing the entire circle, and it is traced clockwise. Okay, so let me stop with that, and I will see you in the next video.